Okay, this is here's paper, paper number one, and the year is October, November 2019, right? Paper one, MCQ, and the variant is 1, 2. Suppose this is a question. Cyclist has a speed of 5 meter per second and the small car has a speed of 12. Which statement does not give the reasonable estimate? Look, kinetic energy, half mv square. Suppose the mass of the cyclist is 60, so half mv square, 1 by 2 is 65 square, so it becomes 750, or approximately 0.75 in 10 power 3, or close to 1 in 10 power 3 joule. And for the car, approximately mass is 1000, so 1 by 2, 1000 into speed square, so it becomes almost 7.2 10 power 4. And the momentum is mass into velocity. So 60 times 5 is 30 and 1000, 12,000. Look at this. First option, kinetic energy, yes, possible. Kinetic energy of the car, approximately 7 in 10 power 4, yes, possible. Momentum of the cyclist, 4 into 10 power 2 is possible. So this is wrong. 2 into 10 power 5 is not possible. Next question is, which expression gives the SI base quantity? Look at the first. Charge per unit time, mean I is equal to Q by T. So look, the first is correct because I is the basic physical quantity. So I is equal to charge divided by the first one. And which list contains only the scalar quantities? Kinetic energy, speed, power. In the A part, displacement vector. In C part, momentum vector. In D, velocity vector. So the answer is B. Now come to this. Micrometer is used to measure 28.50 millimeter width of the plastic ruler, and the micrometer reads to nearest 0.01. So what is the correct? Look, so actually it is 28.50 plus minus 0.01, which can be written as 28.5 plus minus 0.01 in 10 power minus 3 because this is millimeter, so it will be in meter. Now we have to write this in 10 power minus 2, so it can be written as 2.80 plus minus 0.01 10 power minus 2, so the answer is C. And the next question is question number 5. Question is, dimension of this cube is given. This is cuboid. It's 40, 10, 20, all are given in millimeter. What is the percentage uncertainty of the calculated volume? So the volume is length, width, and height. It's a percentage for volume. Percentage of length, percentage of width, percentage of height. So 0.1 divided by 40 into 100, 0.1 divided by 10 into 100, plus 0.1 divided by 20 into 100. So it's approximately 1.75, mean 1.8. So the answer is B. Next question is, a ball is thrown vertically upward from the ground level and reaches a maximum height of 12.7. What is the total time for which the ball is in the air? Look, S is equal to UT plus half AT square, 12.7. If ball is dropped from the height, so initial speed will be 0. 1 by 2, 9.81 into T square. So after calculation, the time is, one side time is coming 1.6. So double, two-way, it becomes 3.22. So the answer is B. Next, the snooker ball has a mass of 200 gram. It hits the cushion of the snooker table and rebounds. So the question is, the ball arrives at the cushion with a speed of 14 and it leaves it with a speed of 7. The ball and the cushion are in contact for the time of 0.6. What is the average force? So the average force is the change in momentum divided by time. So m, v minus u over t. Final velocity is minus 7 because in the opposite direction. Initial is 14, so mass is 0.2 and the time taken this, so it's approximately 7.0. So Newton, so answer is D. Next question is, a tennis ball is released from the rest at the time 0 and falls through air for a long time. So definitely it will achieve terminal velocity. Which graph of the displacement s against time best represents the motion of the ball? So displacement time graph, gradient is speed. So initially speed 0, so gradient 0, it increases and then becomes constant. So D is the answer. Uh, Next question is, a space probe, Rosetta, was designed to investigate a comet. The probe consists of the orbiter and a lander. The orbiter has a mass of 170 and the lander 100. When two parts separated, the lander was pushed towards the surface of the comet so that its change in the velocity towards the comet was 3. The question is, what was the change in speed of the orbit? Initial momentum is 0. So the final momentum m1 v1 plus m2 v2. So both are moving in the opposite direction after the interaction. So m1 v1 is equal to m2 v2 for the lander. 100 mass, velocity 3. Next mass for the orbiter is 170 into v. So v becomes 1.8. So answer is A. Next question is, a positively charged oil drop falls in air in a uniform electric field that is vertically upward. This is the direction of the field. The droplet has a constant terminal velocity and the electric field strength is E. The magnitude of the force due to the air resistance on the droplet is proportional to the speed of the droplet. Which graph shows a variation with E of V naught? Look, when E increases, definitely force on the droplet increases. Upward force becomes greater than the downward force. So due to this, in equilibrium, terminal velocity decreases and finally becomes 0. So this is the answer. Because E is increasing, force is increasing. When upward force becomes greater than the downward force, so it will accelerate. When definitely it will accelerate, the terminal velocity becomes 0 because the terminal velocity is the constant velocity. Next question is, at which position is the pressure is greatest? So all are bearing equal atmospheric pressure. So we have to look at the depth of the water. So B is the point which has deeper. The depth of the water at B is more. So this B is the answer. And the next question is, the gas in the engine does work on the piston of the cross-section area 80. The pressure of the piston has a constant value of this. How much work is done? So look, work is pressure multiplied by change of volume. Pressure given 4.6 10 power 5 and the area given 80 centimeters square into 10 power minus 4 for the meter square, and then the height is 25 centimeters, so we will write 0.25. It is approximately 920, so 9.2 into 10 power 2. This is the answer. Next question is, a power station using coal as fuel has an average mass output of 3000 megawatt. Coal is supplied by 20 trains each day. The efficiency of the station is converting the thermal energy released from the coal to the electric energy in 26%. A mass of the 1 kilogram of the coal will release 33 megajoule of the thermal energy when burned. Which mass of the coal does each train burn? Look, mass of one train. The mass of the coal in one train, M. How many trains? 20. Multiply by 20. And each mass is carrying this much energy divided by time taken is the power. This is the power carried by the each train. Now, 26% of the input power is 3000. So what is the input power? This. Now, this 7.63 10 power minus 3 into m is actually this one, which is the input power, because the code is providing the input power. So m is equal to 1.5 10 power 6. So the answer is C.